For the next one, again, we're just going to replace our a, b, and c into the quadratic formula. So you want to first look at it and say, can I factor this? And if I can't factor it, or if you don't know how to factor it, then you can go right to the quadratic formula and that will give you your x-intercepts. So I have negative 34 plus or minus negative 34 squared minus 4 times 1 times 2, 89, all over 2 times 1. When I simplify that, I get 34 plus or minus the square root of 0, actually, over 2. When I simplify that further, that just means that I'm not adding or subtracting a number because it's that root 0. So we have 34 over 2, which is equal to 17. So what that means is that we only have one x-intercept. And if we only have one x-intercept, that's because it's the vertex that's actually on the x-axis. Now here we have a negative 16. Well, we learned in our complex numbers that we're not going to just jump to the words no solution anymore. We're actually going to simplify it. So negative 16 is the same as negative 1, the root of negative 1 times the root of 16, which is just 4i. I can simplify that to be 6 plus or minus 4i over 2, which is 3 plus or minus 2i. So what that means is that we have these complex numbers, and it just shows that we actually don't have specific x-intercepts. If we're asked to check our solution, we can do that. We just go back to our original question. Equals. And we're going to plug in our value for x that we get. And we can multiply this out. So we can distribute it and multiply it out. On the right-hand side, we get 18 plus 12i. On the right-hand side, I'm going to just go up here for a second. If we FOIL these, our first is going to give us 9. Our inner and outer give us 6i together, so twice. And our last gives us 4i squared. And then we have that plus 13. I'm going to collect like terms. So I get 9 plus 13 is going to be 22 plus 12i, which is going to cancel on that right-hand side, minus 4. And again, we get that minus 4 because we have 4i squared, and I squared is equal to negative 1. So it's 4 times negative 1. These will cancel. 22 minus 4 is 18. So we're good. Now, we have this term called the discriminant, and the discriminant is the actual expression that's found underneath the radical in the quadratic formula. So it's just the b squared minus 4ac. And if you think back to the examples that we just went through, if we simplify that and the solution was a positive number that was greater than 0, we would always end up with 2 different x-intercepts, regardless of if they were real or rational. And then in the next example, it simplified where the number underneath the radical, so which is called our discriminant, was equal to 0. And that just means that when we have our plus and minus, we're adding 0 or subtracting 0 in the quadratic formula. So therefore, we only have 1 x-intercept. And if the number was a negative, that means that we have 0 x-intercepts because it ends up being an imaginary number. So it says use the value of the discriminant to describe the number and type of roots. So my a value here is going to be 1, b is equal to 3, and c is equal to 5. I'm going to plug that into my discriminant formula. So this is another formula that you have to know, even though it's derived from the quadratic formula, it does have a different name. We plug in 3 squared minus 4 times 1 times 5, which is 9 minus 20, which is negative 11. So this is a negative number. So if we go back to the sheet, if it's a negative number, that means we have 2 complex roots. So we would say 2 complex roots. Let's try another one. Our a is equal to 1, our b is equal to negative 11, and our c is equal to 10. We sub that into our formula. which is 81. So if we have 81, that means that the number underneath that square root is equal to 81. So therefore, if I go back to the chart, it's a number greater than 0, so it's either one of these two. And because 81 is a perfect square, it's two real rational roots. Two real rational roots. So on this last screen, it just kind of goes through different ways to solve quadratic formulas. We can graph them, which we've talked about. We can factor and use the zero product property, setting them equal to 0. We can use the square root property, where we're taking the square plus or minus square root of each side to solve. We can do completing the square and the quadratic formula. All of these are helping us solve the quadratic, and again, when I say solve the quadratic, that means finding the x-intercepts, if there are any.